Hi everyone. So today's topic is something called average value, and I hope that doesn't sound too terrifying because it's really not. I've covered this up because I kind of want to talk about why we need an average value calculation before I show you how to do it. But really I'm just teaching you one teeny tiny thing that you can add on to what you already know about integrals. If these problems feel long to you, it's not the average value piece that takes a long time. It's really just the stuff that you already know how to do. So things like finding an integral, finding a maximum, those kinds of things can all come up in these questions. So, but average value by itself is really no big deal, okay? And it's just something that gets mixed in with all these other multi-step questions. So I trust that every single one of you could find an average value if I gave you a list of numbers. So let's say that we're meteorologists and we collect data on snowfall. And so we list it by day and we say, okay, on Monday we got 2.4 inches of snow, and on Tuesday we got 3.8 inches of snow, and Thursday we got 1.2. I think I lost track of which day I was on, but you get the point, right? Like if I gave you a whole list of numbers like this, you all know that you could add them together and then divide by how many there are, and you would find the average. Okay, so that's not rocket science. That's not anything new. But what I want you to think about is what you would do in the event that instead of me giving you a list of numbers like this, what if I gave you a function that modeled, let's say, temperature over time? Okay. And time is continuous, right? So I can take the temperature at 8:04, and I can take the temperature at 8:07, and I can take the temperature at 9:15. I can take the temperature as many times as I want, and I can make a continuous function out of it. So maybe my temperature does something like this, okay? How do you find the average now? Because it's not like you can add up all the values. There's an infinite number of values here on this function, okay? And so that's the situation that we're talking about today. Is it's the same concept as this average, but I don't have a way to add up all the values. I mean, sure, I could pick some values off of here and get a pretty good estimate, but like if you chose values and I chose values, we're not guaranteed to pick the same ones, so we'll get different answers, okay? So we want to figure out how do we take an accurate average with a continuous function, okay? And the way we're going to do that is with integration. So if I were to take the integral of this function, that's going to find this area, okay, and we'll just say this is up to 5. We'll do this as in days. So we'll say this is up to 5 days. It started at 0 and went to 5, okay? And so we're going to call this f of t. And what I just did is I integrated f of t from 0 to 5, okay? And what that would tell me is the accumulation of temperature, which is a really dumb measurement. It's not really anything helpful, right? That would tell me that if I added up all the degrees on every day for 5 days, okay, this is how many total degrees my thermometer read at some point. And nobody ever cares about how many total degrees you have, especially not if you know you're 78 at 2 o'clock and you're 78.2 at 2:30, and you add those together, like what does that even tell you? But what this is doing when you take this integral is adding together all of these individual function values, right? That's what this accumulation is the accumulation of whatever your function is. And so now if I want the average, I can just take that and say, all right, I'm going to take this and divide it by the 5 days. And that will give me my average temperature per day. Okay, so that's the idea behind average value, is we can find average values of functions by integrating them and dividing by essentially the width of the interval. Okay, so that's what's going here on the top of your paper. There's the definition of average value, which is basically what we just talked about. This line right here explains what we just did. Feel free to pause if you need a minute to get things copied down. But found by calculating the integral and then dividing by the width of the interval. Now, I said back here that I would divide by 5. The way this is written where you would multiply by 1 over b minus a. That's essentially like back here me saying that I would multiply by 1/5 instead of dividing by 5. Okay, it really doesn't matter. It does the same thing. But the idea with an average value is you're just going to integrate, and this part we already know how to do. The only new thing is now we're going to multiply by this 1 over b minus a, okay, which is the width of the interval. So in this first example, and by the way, we're not going to answer this question. This is more of an Algebra 2 question, not super necessary, but find the average value of f of x on this interval. Okay, so we know that if we're looking for average value, we want to integrate 6 minus x squared on the interval from -1 up to 3. And the only new piece here is that now what I'm going to do is I'm going to divide, or I'm going to multiply by 1 over this width. So mathematically what I'm really doing here is 3 minus -1. That's really going to be a 1/4. Okay? So, or I could think of it as dividing by 4 at the end. That's fine too. What I'm going to do from here, the rest of this is old stuff. The rest of this is I'm going to find an integral. I'm going to do this by hand. We're going to do an antiderivative. We're going to plug in endpoints. I'm going to crunch all the numbers, but I'm probably going to fly through that part pretty quickly because that's not new stuff. So now would be a really good time for you to pause the video and start working on it ahead of me and see how far you can get. See if you can get yourself all the way to an answer here. But this is the math that we're doing. It's just this integral here. Okay, hopefully you took my advice. So this is now 1/4. And then my antiderivative, 6 is going to become 6x. And negative x squared because negative 1/3 x cubed. And I'm taking that from -1 to 3. Okay. Well, that's going to be, oh, forgot my 1/4. I'm dropping in the 3, so 6 times 3 is 18, minus 3 cubed is 27 divided by 3 is 9. Oh, I need a double parenthesis there. Minus, here I am dropping in -1, so 6 times -1 is -6. And then -1 cubed is going to be -1 times a -1/3 is going to give me a positive 1/3. Okay, there's my second parenthesis. Okay, so let's say this is now 1/4 times 9 minus, now over here, this 6 here, I want to make a common denominator, so I'm going to make it 18 over 3. So that this is now -18 plus 1, so this is now -17 over 3. And then I want a common denominator with the 9, so I'm going to make this 27 over 3. So what I really have now is 1/4. This is 27 plus 17, so that's 44 over 3. And then to do this 1/4, which by the way, that 44 over 3, that would be just your integral, right? This 1/4 is the part that came from the average value. I'm essentially dividing 44 by 4 here, which is 11. So my final answer here comes out to be 11 over 3. Okay. And that's it. That's my average value. Okay. Now, just to point out, this question that I crossed out would just mean that I'm going to take this 6 minus x squared, set it equal to 11 over 3, and then solve for x. That'd be really easy to do with a calculator, a little less easy to do without one. We could probably factor or something, but that's a lot more of an algebra question, so I'm not so worried about that. Okay, there's an important note here. It says, be careful, do not mix up average value with average rate of change. And there's kind of a way to tell the difference, okay? Average value will always have the same units as your original function. Okay, so if I give you, let's say that example that I started with temperature. If I give you a temperature function and I ask you for the average temperature, that is an average value. So you're going to integrate and divide, because when you integrate, you're doing an antiderivative, but then when you divide, you're kind of bringing it back down to the same units you started with. An average rate of change, that's when you're looking at like a derivative or a rate, okay, and then you'll usually have your units become something per time or whatever it happens to be. Okay, so if I did an average rate of change on that temperature function, which is like a slope calculation, that's telling me how much my temperature is changing per hour. And notice my per hour, okay? If I want just an average temperature, that's when I'm doing average value. If I want average rate that the temperature is changing, that's when I do AROC. So maybe this next example will make that a little more clear. This next example is a height function. We're going to do this one with a calculator, by the way. So negative 16t squared plus 41t plus 10 measures the height of an object over time. And notice it's asking about the average height. Okay, this is height, right? These two things match. So if I'm asking you for average height and the function is height, that's where I'm going to integrate and do my 1 over whatever. So I'm going to do an integral of h of t, and it says in the first 3 seconds. So again, the reason I have to do this integration thing is I could find the height at 1 second and at 2 seconds and at 3 seconds, but there's heights in between there, right? And I can't possibly add together all of the heights that it hits between 0 and 3 seconds. But integrating does that for me. And then to make it an average, I'm going to divide by 3. Okay, like I said, we'll use the calculator for this one. I'm going to do, and you can do it all in one step, so I'm going to say 1/3 times math number 9, 0 to 3, and then my function is negative 16x squared plus 41x plus 10. Okay, don't forget my dx here. Actually, I want to say something real quick here. You absolutely could just hit enter and that would just give you your answer, but let me take out the 1/3 for just a second because I want to make a point. So this is just my integral, right? And that 70.5, that would be like the accumulation of height, which again is a ridiculous number. It doesn't mean anything to us because that means that I added together all of the heights that I was at between 0 seconds and 3 seconds. Okay, and adding those heights together doesn't make any reasonable sense. But if I then take that and say I'm going to divide by 3, which is the same as multiplying by 1/3, now this is the average of all of those heights. Okay, so if I look at like how high I got and how low I got, and I added up all of those possible heights and divided by the 3 seconds, this is how high I was. This is the average height that I reached. Okay, so 23.5 feet. And again, notice my units. This is feet, this is feet. My units stayed the same. Okay? Now, if I ask you about velocity, velocity is change, that change word is important, in position, which in this case, position is really the height. So this is not asking you about height, it's asking you about change in height. And that's where we're using AROC. Okay, it's still the first 3 seconds. So what I want to do is I want to do h of 3 minus h of 0 over 3 minus 0. And this does get a little confusing because you are still dividing by 3 here. That's what's happening. But my h of 3 is negative 16 times 3 squared plus 41 times 3 plus 10. Hope I typed that in right because I can't really see my buttons. Here I get negative 11. Oh, I have a negative height, huh? All right. Negative 11 minus, and my height here is 10. Sorry, that's h of 0. If I put 0 in here, those would all be zeros. And then I'm dividing by 3. I'll look one more time, and it very well could be just that, yeah, I think this one just has negative height. We must be measuring it against something that's not like ground level or, you know, maybe the top of a swimming pool or something like that. But this is what we end up with. And negative 11 divided by 3. And we end up with negative 3.6 repeating. And that would be feet per second. Okay, and this number does make sense as a negative. The height at 3 seconds being negative is a little bit weird, but again, if we're calling like 0 the top of a building and I'm falling right? Then we could consider that to be a negative height. But this is a negative velocity, okay? This is an average velocity, and that means on average, I'm moving this quickly in a negative direction, which probably means that I'm heading downward, okay? So that does explain the negative height. Okay, last one. Temperature outside during a 12-hour period is, here's this function. Find the average temperature over the 12-hour period. I would really love it if you would pause this video. You can use a calculator on this if you need to, and see if you can come up with this average value. I'll just get it set up here. So my average, let's see, this is over a 12-hour period, so it's going to be 1/12 times the integral from 0 to 12 of this function, t of h dh. All right, 1/12 times math number 9, 0 up to 12. Oh, missed my 0 there. And my function is 60 minus 5 cosine of pi x divided by 8. Close off those parentheses. Don't forget your dx down at the end. Oh, I messed up my dx. Okay, this should have an x. This should not. Sorry about that. There we go. Okay. And so our average temperature over that 12-hour period is 61.061 degrees. So notice average temperature, and the function was temperature. So that's when I'm doing this average value thing. When the thing that you're averaging is exactly the same thing as the function you have. If I wanted you to do an AROC, if I wanted you to do like a rate of change or a slope calculation, you'd be looking at the change in temperature somehow. So how fast is the temperature changing? But that's not what this question is asking. So just make sure you know the difference between those two. Your homework assignment tonight has several questions that have a lot of review content in them, but the one little new piece that I'm starting to sprinkle in here is finding average value. So you'll be practicing a lot of good things, but you'll just kind of hit this as it pops up in each individual problem. So thanks for watching.